You ever find yourself streaming a movie, maybe in the middle of nowhere, and you just stop and think, how is this even happening? I mean, we all carry these little magic boxes around, but the reality of how they actually connect to everything is so much crazier than you'd imagine. So, today, we're going to pull back the curtain and take a look at the massive, hidden physical network that powers our wireless lives. All right, let's get into it. So, let's just start with this one really basic question. We call it a wireless phone. We talk about our data being up in the cloud. But is that really what's going on? Is your connection actually wireless? Well, here's the truth, and it's a piece of engineering that is almost unbelievable. Your phone isn't some magical separate thing. It is literally the final link in the single largest and most complicated physical machine that humans have ever built. A machine that crosses continents and dives to the very bottom of the ocean. Okay, so this right here busts one of the biggest myths out there. A lot of us have this picture in our heads of our phone signal beaming way up into space to a satellite and then back down. But look, if that's how it actually worked, every phone call would be incredibly annoying. You'd say hello, and there'd be this long, awkward pause. No, the reality is your signal makes a really short hop to a nearby cell tower, and from there, it plunges into a hidden network of fiber optic cables traveling at nearly the speed of light. So, if it's not satellites, how does your voice actually get from you to your friend across the country? Let's follow the signal, starting from the exact moment you start talking into your phone. Inside your phone, this incredible little three-step translation happens in a split second. First, the microphone takes the analog sound wave of your voice and turns it into digital code, just a stream of ones and zeros. Then the phone's tiny antenna takes that code and basically stamps it onto an invisible radio wave. And finally, whoosh, the antenna sends that wave out into the world. Your voice is officially on the air. And what is that wave exactly? Well, think about regular light. Light is an electromagnetic wave, right? But it can't go through walls. A radio wave is the same kind of energy, but its wavelength is much, much longer. Imagine stretching out a slinky. That longer wave has the power to travel for miles and go right through buildings, which makes it the perfect vehicle for carrying your conversation. But here's the catch. These radio waves, as cool as they are, aren't all powerful. They have limits. They can't just go on forever. And that's where the real genius of the mobile network really kicks in. So, the early engineers had two massive problems to solve. First, a radio signal from a single tower can only go so far before it fades out. And second, there are only so many radio frequencies to go around. If everyone tried to use the same frequency at once, it would just be total chaos, a mess of signals all talking over each other. And the solution they came up with was just brilliant. Cellular technology. Instead of trying to cover a huge area with one giant powerful tower, they broke the landscape up into this honeycomb pattern of smaller areas, or cells. Each little cell gets its own low-power tower. And this setup lets them do an amazing trick called frequency reuse. See, as long as two cells aren't touching, they can use the exact same frequencies without messing with each other. It's genius. Suddenly, a limited number of frequencies could support millions of users. Okay, so your voice is now a wave. It's been caught by a cell tower in your little cell. But what happens next? Where does it go from there? This is where the story takes a really interesting turn. And this is the moment that completely shatters the whole wireless illusion. Your signal hits that tower, and its journey through the air is over. It doesn't go up, it goes down. The tower's one and only job is to catch that radio wave, instantly turn it into a pulse of light, and shoot it into a hidden superhighway buried right under our feet. So this is what the network actually looks like. The cell towers are kind of like the on-ramps. They get your signal onto the highway. But the highway itself, that's this massive global web of fiber optic cables. And directing all of this traffic, those are the brains of the whole operation, mobile switching centers, or MSCs. Think of them as the network's air traffic control. Okay, so we've got this gigantic network of towers and cables. But with billions of us moving around all the time, how in the world does the network know exactly where to send your call? Well, that's the magic of the MSC. The mobile switching center is basically your phone's home base. When you first get your SIM card, you're assigned to what's called a home MSC. And that MSC's job is to keep track of you. It maintains a constantly updated record of which cell tower your phone is closest to, no matter where you are in the world. So let's walk through it. You decide to call a friend. Your phone sends that request to your home MSC. Your MSC immediately contacts your friend's home MSC and basically asks, hey, where's your guy right now?
Your friend's MSC instantly replies, "Oh, he's over here near this specific tower in Denver." And then, bam! The network creates a dedicated path through thousands of miles of fiber optic cable to connect your tower to his. All this happens in the blink of an eye. It's just incredible.
This whole system is already amazing, right? But what's even crazier is how engineers have just kept making it smarter, faster, and way more efficient over the decades. You know, the evolution you see here is really all about one thing: figuring out how to pack more and more data into the same radio waves more efficiently. 1G gave us those big, clunky analog phones. Then 2G came along, went digital, and boom, we got texting. 3G is when the internet first showed up in our pockets. 4G made that internet fast enough to actually watch movies. And now, 5G is laying the groundwork for a future where everything is connected, from our homes to our cars. So, the next time you pick up your phone, just take a second to think about the incredible, invisible symphony of towers, cables, and code that makes it all work. To go from simple phone calls to a totally connected global society in just a few decades is, well, it's an unbelievable achievement. Which leaves us with one last thought. As we push forward toward things like 6G and even quantum networks, what will a world with truly instant, unhackable communication unlock for all of us?